Good morning, ladies and gentlemen. We are going to do the first half of section 4.6 today. We are going to talk about a new topic for you guys, complex numbers. And we are going to do some math on our complex numbers. We are going to add, subtract, and multiply. So our objectives for the day, first we're going to define the imaginary unit of I. Okay? It's actually kind of a fun topic. Then we are going to solve some quadratics with complex answers. Okay. And then we're going to do some math operations with our complex numbers. So those are the three tasks that we are going to do today. So we're going to define our imaginary unit I. We are going to solve quadratics with complex answers, and then we are going to do some math operations with our complex numbers. All right, so our first definition is going to be that the square root of a -1 is equal to I. So in the past, when you would try to solve a radical and you got a negative under the radical, in previous years, so in previous times, you would have said no solution. But in fact, there really is a solution. So now we do have methods to solve. Okay, so now we can manage our negative underneath the radical. All right, so our I is actually called an imaginary unit. Okay, all right, so we can actually solve a quadratic now, and if I get a negative under the radical, now I can manage that. So the way that we do it, if I have, let's say I'll make this a negative square root of a -4. So this is the radical of a -4. I can rewrite the radical as a -1 times the square root of 4. Okay? So then I know that the square root of a -1 is equal to I, and I know that there's my square root of 4. And then I could actually simplify it one more step. The square root of 4 is 2. Would be plus or minus 2, because anytime you do an even root, you get a plus or minus 2. And then there's my I. So that would be the solution to the square root of a -4. Sorry, I had to take a little coffee break. Okay? So let's do a couple of quick examples using our square root of a negative number. So let's do an example that asks you to solve the quadratic. All right, so I'm going to give you a quadratic equation. 2x squared plus 11 is equal to a -37. So that's going to be our first example. If you'll notice in the example, I have a squared term, but I don't have any other variables. So what I'm going to do is put the numbers on this side, and then I'm going to manage my x squared on this side. So I'm going to have 2x squared is equal to a -37 minus 11. So then I'm going to have a 2x squared is equal to a -48. Okay. Now I need to divide both sides by 2, and I'm going to get x squared is equal to a -24. Now I need to take the square root of both sides, and I'm going to get x is equal to the plus or minus the square root of a -1 times the square root of 24. Okay? And then if you'll remember from our previous lesson, I'm going to reduce my radical. Okay? So 2 would go into 24, 12 times. 2 would go into 12 6 times. That's a weird 6, sorry. So I'll scribble that out. That's a 6. Then 2 goes into 6 3 times. 3 goes into 3 1. Remember that you can't go outside to play unless you have a buddy. So 24 reduces to be 2 radical 6. So now I can use that information to simplify this problem. So now I'm going to have x is equal to, there's my plus or minus, there's my I, and then I would have 2 radical 6. Okay? You'll also see this written as plus or minus 2 radical 6 and then I. They're still multiplied together, but oftentimes we put the real component of the number first and then the I on the outside edge. All right, so that's our first example. All right, so now let's do another example, kind of along the same lines, just an additional example to help us manage our math. So again, I want to solve, and I'm given x squared minus 8 is equal to a negative 36. Sorry about the focusing. All right, so if you'll notice again, it's the same type of situation. I have a squared variable, but I don't have any other variables, so I'm going to move the 8 to the other side. So I'm going to have x squared is equal to a negative 36 and a positive 8. When I combine those terms, I get x squared is equal to a negative 28, sorry, bad math. And now I'm going to take the square root of both sides. Hopefully we can get it focused. It's a little better. So I'm going to take the square root of this side and the square root of this side, and I'm going to get x is equal to plus or minus the square root of a negative 1 times the square root of 28. I'm going to reduce 28 with my t that we learned a couple of days ago. So 2 goes into 28 14 times, 2 goes into 14 7, 7 goes into 7 1. There are my buddies. Those get to go outside. So it reduces to be 2 radical 7. So now my solution is plus or minus 2 radical 7 I. Okay? So yes, you can actually take the square root of a negative number, and I manage that by introducing the variable I. Okay? All right, so now we need to talk a little bit more about our complex numbers and kind of their standard format. So they have a couple of rules. So the standard form is always going to be A plus BI. Okay, and this becomes very, very important. Okay, you cannot write it as BI plus A. That's a no-no. Okay, you have to write it as A plus BI first. All right, the A is the real component, so it actually will be a plain number that we are used to seeing. Okay, so the A is going to be my real component. The BI is called your imaginary, sorry, I spelled it wrong, imaginary component. And when I put those two things together, it makes a complex number. So a complex number is made up of a real component and an imaginary component, and together those two things make up an imaginary number. All right. Your book also introduces the concept of a pure imaginary number. Okay. And all that means is that there's no A. So there's no real component, it's just an imaginary number. So if I had 2I, that would be a pure imaginary number because it doesn't have a real component. All right, so now what we're going to do is I'm going to show you a little bit of math that we need to pay attention to with our i's. So I know that I is the square root of a negative 1. If I write I squared, by definition of what a square is, that means it would be a -1 times the square root of a -1, and that's going to give me a -1. This one and this one are the two most important because we will use this in simplifying many of our equations later. Okay, so just to show you an extension, if I have I cubed, that means I could do I to the squared times I to the first, because if the bases are the same, I add the exponents at the top. So this would be a -1 times the square root of a -1. And we would just simplify that to be a negative radical -1. Okay? If I do I to the fourth, I could kind of use the same idea, and I would do I squared times I squared. And when I get that, that would be a -1 times a -1, which would give me a +1. We're almost done. We'll do one more. So then if I do I to the fifth, okay, and I'm going to write it you could do it a couple of different ways, but I'm going to write it this way. I could do an I squared times an I squared times an I to the 1, because if the bases are the same, I add the exponents at the top. So there's 2, 4, 5. So then this would be a -1 times a -1 times the square root of a -1, which just means the square root of a -1. And now the pattern would continue. Okay, so then this would be, our pattern would have developed, and then you could, if you kept going, if you did I to the 6, I to the 7, I to the 8, you would notice that your pattern had repeated. Okay? And again, I'm going to say, just if we manage our I squared is a -1. You must remember that because we will use that to simplify other expressions. All right, so now that we've kind of done all of our definitions, what we're going to do is do some math operations. Make sure you can see, so there are our math operations with our complex numbers. All right, so we're going to start doing some math operations. We usually learn new concepts with adding and subtracting. So we're going to do adding and subtracting. Whoa, now I'm focused. Adding and subtracting first. So here's your first example. If I have 8 minus I, and I want to add it to 5 plus 4i. The I represents the square root of a -1, but it also is treated very much like a regular variable. So just like regular algebra, the like components work together, and so then I would put the numbers together and the i's together. Ooh, nice smile. So then I would group my 8 and my 5 together, and then I would group my -i and my positive 4i together, and then I just simplify. 8 plus 5 is 13. 4 minus 1 is a positive 3i, and there's your answer. Okay, so the math isn't difficult. I just combine my like terms. So now let's do another example. Okay, all right, I would do a 7 minus 6i, and then I'm going to do minus 3 minus 6i. So the thing you need to be careful with is this negative, because I'm going to distribute that to both terms on the inside. So this would become 7 minus 6i minus 3 plus 6i. All right, because I distributed the negative to both terms. Notice that I have a -6i and a positive 6i, so those terms actually cancel. And then if I simplify, I have a 7 and a -3, and then I'm going to get 4. So I actually lose the complex component for this particular number. All right, so now we've done addition and subtraction, so now let's do multiplication. Okay, multiplication is more fun anyway. So now let's do some multiplication. So here's our first example for multiplication. if I have 4i and I multiply it by a negative 6 plus I, just as you would do all other math, I'm going to distribute the 4i to everything on the inside. So I'm going to get a negative 24i, and then I'm going to get 4i squared. But remember, we talked about I squared is equal to a negative 1. So then I have to simplify this. So this is going to be a negative 24i plus 4 times a negative 1. So this is a negative 24i minus 4. Key thing to notice, this is not in standard form. Therefore, you have to rewrite it. So it's a negative 4 minus 24i, and that would be your answer. I know this seems a little bit silly right now, but it's very, very important when we get to graphing our complex numbers. It will make more sense. So for right now, you just have to trust me, and you have to accept that in standard form, the real component comes first, and then your imaginary component is going to come second. All right, we're almost done. I have just a couple more examples of multiplication. All right, so the next one, we're going to do 9 minus 2i, and now I'm going to multiply that by a negative 4 plus 7i. So just like we did earlier in the chapter, I'm going to put this in a box because I think we lose less things and we manage our math better when we put it in a box. So I'm going to put the 9 minus 2i on top. Doesn't matter where I put it, and I'm doing a negative 4 and my plus 7i on this side. Now I'm going to fill in my cells. 9 times a negative 4 is a negative 36. 9 times 7 is going to be 63i. A negative 4 and a negative 2 is a positive 8i. And a 7 minus 2 is a negative 14i squared. All right? So then let's pay attention to our I squared. Remember that this is going to become a negative 14 times a negative 1. So this actually becomes 14 in that last cell. Here are my like terms, and here are my like terms. So now if I finish that math, I'll come over here, so I'm at the bottom of the page. So I have a negative 36 plus 14, and then I have a 63i and an 8i. So if I finish doing that math, I'm going to get a negative 12 plus 71i, and that would be your answer. So the thing to notice about multiplying complex numbers is if I have an I squared, I have to change the signs because I'm multiplying by a negative 1. So that's usually the component that we tend to forget. All right, you're almost done. I have one more example of the multiplication that we just did, and then I'm going to give you your problems. Okay? All right, so here's your last example. And again, it's going to be our multiplication. So I have 7 minus 2i, and I'm going to multiply that by 3 plus 4i. And again, I'm going to do my box because I think we lose numbers less when we manage it in a box. So I'm going to put my 7 minus 2i on the top, and I'm going to put my 3 plus 4i on the side. And now I'm going to start filling in my boxes. So this is 21. This is 28i, this is a negative 6i, and this is a negative 8i squared. Remember, if I have an I squared, this is going to equal a negative 8 times a negative 1, so that's going to give me a positive 8, so I'm going to put it right there so we know it goes there. Now I have my like terms along my two diagonals, and I'm going to get 21 plus 8, and then I'm going to have a 28i and a minus 6i, and so my final answer is going to be 29 plus 22i. And again, noticing that my real component comes first, my imaginary component comes second. All right, so now your video is over. and I'm going to give you your problems. You actually have 5 to do today because the first, actually that's not true, a couple of them are super fast, and so I want you to have a little bit more practice. So your first one is going to say solve, and they're going to ask you to solve 9 minus 4y squared is equal to 57. Your second problem is also going to ask you to solve, so we can get some work in on solving those quadratics with our complex numbers, a negative 112. Your third one says do math. We like math, so I'm just going to write down the directions as do math. And you're going to have 6 minus 3i, and you're going to add that to 5 plus 4i. Problem number 4, we're still going to do math because we like doing math. And I'm going to have a negative 2 minus 6i, and I'm going to add that, oops, sorry, I changed my mind. We're going to subtract it from 4 minus 6i. Okay, so please excuse my scribbles. And then your very last problem. Again, we're going to do math. Woohoo! We love math. And I'm going to do 3 plus 2i, and I'm going to multiply that by 4 minus 6i. All right, those are your 5 problems for the day. Hope you have a lovely weekend, and I'll see you on Monday.